classroom, Jade. In your lecture class, this is an impedance. This is a combination of resistance. That means, let me go with, okay. Which circuit is this? Can you tell me which circuit is this? RC. And about this, what is this? RM, right? And the another one is what circuit is this? RC. So these are the three circuits that we studied already, right? So basically, the jet thinks it's a combination of, now remember, this is a resistance R, right? And the resistance, there is a resistance or there is an opposing current, isn't it? There is an opposing current in this capacitance as well. We call this as capacitance reactance, which is denoted as XC. This opposes the current. So if this opposes the current, this is also the another type of resistance, isn't it? You know the definition of resistance, right? We have studied in your lecture class. The definition of a resistance is the one that opposes the current, right? So if this XC, it opposes the current, so this is also the one type of resistance. It's a resistance of this capacitance. So it is called an XC, which is named as capacitance reactance. So there are two resistance over here. That is one is R, another one is XC. So the total resistance, which is called as J, impedance, it is equals to root under R square plus this one is XC square. So this is a total resistance in a circuit. So if there is one or more than one resistance, then we call it that as Z impedance. So it's same like this. Here is XL, here is R. So that means Z is equals to R square plus XL square. Here is R, here is XL, here is XC. The Z is equals to, now here is little different, that is R is equals to, it's this one, that is XL minus XC square. Because both of them opposes the same current, isn't it? So if it opposes the same current, so we need to subtract it, that is XL minus XC square. This is a formula. You are not going to prove this one, so you just remember it. So this is a total impedance. This is a major formula. So if there is RCL circuit, this is a formula for total resistance, that is impedance. If RC is only there, XC, XL, that will be 0. It's R square plus XC square. And if there is RL, XC is 0, that means there will be R square plus XL square. This is very important, and I think it is very clear through this circuit about the name Z impedance. So another thing, you know the DC and AC current, I won't explain a lot, I will just say basic things. Direct current, alternative current, the thing is that I want to explain just a simple thing. The circuit that we learned before, if there is connected with a battery like this, and this is of 8 volt, and it says battery, we studied this already, right? This type of question, that was a DC current. So I will just say here battery. Obviously battery will come here as well, but if nothing is nothing is said in the question, or nothing is mentioned about DC or AC in a question, then remember that's a direct current DC. That means you are going to apply a simple Ohm's law. Obviously we are going to apply the Ohm's law over here as well, but the basic law over here will be V is equals to I0. Isn't this one, right? But in AC current, remember you can distinguish AC current, even if the question has not said AC current, it's with RMS. Do you know what is RMS? You have already studied in your lecture class, I think. RMS, it's a root mean square. And I think you have proved this as well. This as well. Proof of what? The IRMS and VRMS things, which is over there. You have already proved in your class. So here what happened? If the RMS is mentioned in the question, like as V, voltage root mean square, current mean square, or if there is a maximum current, peak voltage, maximum voltage, then remember that is an alternating current. So if there is an alternating current, obviously you are going to use the Ohm's law same, Ohm's law, but the certain difference will be, instead of V there will be VRMS, instead of I there will be IRMS, and instead of R there will be Z, that is impedance. Okay, and for Z, if there is two things given, that is resistance XL or XC, you are going to use this one according to the formula, that one. But if just XL is given, that is the reactance of inductance. So if the reactance of an inductor or inductance is given, then you can just assume Z as XL. So if capacitance is given, it's XC, or if resistance is given, it's R. Did you get it? So yeah, this chapter is all about these things. Chapter number 21. I think I almost cover up all the things over here in the, yeah. And the basic thing is your midterm is coming. It's on Thursday, right? Thursday to Saturday. And some, like, most of them complain me about their time because you won't get time to go through all the questions. So what you do, the basic thing is this part is for mainly for you in order to do in your midterm exam. What happens? Look all the formulas that I have given you in everyday's classroom, everyday's class, and write down in like this exercise paper. Write down chapter number 20, write down all the formulas. 21, write down all the formulas and take a sheet of paper and the side. So what you do when you start your exam, you don't go through your notebooks, your book, anything. You just look at the formula, you just remember, oh, this is this chapter question. And you go with all the formula, look which one is suitable, which one is given, apply according to that. So I think it will save you a lot of time. And if there is a conceptual question, obviously it will come from Wright-Fleming's rule, you all know. So if it comes from there, you just use this, you just apply. I don't think you will need any notebook over there. So by that way, you will get a time to save, or you will finish the time. And this is the basic things, or all the things which cover this chapter question, chapter number 21. So we will start the numerical part. And I think if I have explained you a lot in this way, you can solve any question from this chapter, almost all the question. So let's go with the question. Look at the question number 2. It's just a basic formula things. A certain light bulb is rated. Power is given, that is 60 watt. Remember, if there is watt, it's power. And I have written here the formula for power. But I didn't explain you this because I have already told you this in the Ohm's law things, right? That is power is equals to V square upon R. Instead of V square, there is VRMS square. It's a root mean square. So power is 60 watt. VRMS, it's given that is 120 volt. Question is saying find out the peak voltage. Peak voltage means maximum voltage. That means V peak or V max. You need to find it. What is the resistance of a bulb? That is, you need to find the R. Does a 100 watt bulb have greater or less resistance than a 60 watt bulb? And I remember in my undergrad this question came in my exam. So I think you will also get this type of conceptual question in your exam as well. So here let's find out these two things. Can you tell me which formula will you use to find the V max? Which formula will you use to find the V max? It's this one, right? So V max is equals to VRMS times root under 2. So in order to find VRMS, it's 120 times root under 2. You get the Vmax. And for R, what will you do? Power is given. You know the formula, this one. That means V square RMS upon R, or R is equals to V square, it's 120 square. And resistance, power is 60. You'll get something like 60.0. 6 2s are 12. 120 to 40. This is A number 1, this is B number 1. And for C number, does a 100-watt bulb have a greater or less resistance than a 60-watt bulb? So here the things is about power and a resistance. So you just look at this one, the relation of this, that is, we know the relation that is power is equals to V square RMS upon R. This is same for both 60-watt power and 100-watt power. So what happened? For resistance, it's V square RMS upon power. Let us consider this as 61. So power of 60, that will be 60. V square, that will be 120 square. You will get to 40 ohm. And the next one, that is R100 is given. That is 120, it's same. 100. Something like 0, 0 cancel. 0, again 0 cancel. So by saying, looking at this, 60 watt has more resistance, right? And 100 watt has less resistance. So this means very clear that 100 watt power has less resistance than 60 watt power. And why is that so? Write down, because this is a conceptual question, you need to write the reason as well. Because obviously these both are inversely proportional with each other. Because resistance, or you can say power, anything, is inversely proportional to power. That is, R is P, or P is inversely proportional to R. It's very clear. You don't have to write this one. You just can write just this thing. I just wrote this because to explain it. But in exam, you don't have to write this all. Is there any confusion in this question? I don't think so. We can move on to the next question because there are a lot of questions today. But it's easy. Now look at question number 5. A 24 kilo ohm resistor, that means resistor is 24 kilo ohm, that is 24,000 ohm, connected to an AC voltage source which dissipates an average power, that is power is 0.6 watt. Calculate the RMS current, that is IRMS, and calculate the RMS voltage, VRMS. So how would you find out this one? You will simply use the formula, that is power is equals to, first find out the I, that is I square RMS times R. That means I is RMS is equals to root under P upon R. So P is 0.6, R is 2, 4, and you will get the value. For VRMS, just simply use the Ohm's law, that is IRMS times R, which is equals to, what's the value of IRMS? Something like 5 into 10 to the power minus 3. I might be incorrect, you just use your calculator, it's not a big deal. And 5 into 10 to the power minus 3 times resistance 25000. any doubt over there? I don't think so, because it's just a formula I used. And if you feel any confused, just look at these things. If you look at these things, you will get the idea already. We go through question number 8 if we have finished question number 5. So in question number 8, North American outlets supply AC electricity with a frequency. So here the two things is given, or two cases given. One with the North American and another one with the European. So I'll just write down in this way. You can write in any way. And it's European. Okay. For North American, the frequency is given, that is 60 Hertz. And the next thing, while the European standard is frequency is equals to 50 Hertz. Now remember this, I'll just write down the question as well. If you understand this one, you will get every question for this type of case, I think. It's very simple question. I just wanna just tell you what this question is saying. So here, what value of capacitance provide a capacitive reactance of 1 kilo? Capacitive reactance. Capacitive reactance or inductive reactance. If there is inductor. So remember, if this type of question comes, an inductor with the inductive reactance or capacitance with the capacitive reactance, this means this is Xc and this is Xl, which is also a resistance. Opposing current. I don't have to write this one, you understand. So these things. So here in this question, Xc is given for both, that is 1 kilo ohm, and here also Xc is given, that is 1 kilo ohm. Question is saying what value of capacitance, that means you need to find C. You need to find C over here. Is there any confusion? No. So this is the question. You already understand the question. Find the answer now, because it's very simple. Because there is one formula in order to find this. It's Xc is equals to 1 upon 2 pi Fc. F, it's a frequency. So now Xc is equals to 1 upon 2 pi Fc. Don't get confused over these things. Xc is 1 over 2 pi Fc and XL, it's 2 pi Fl. The reciprocal thing and the normal thing. So it's equals to, you need to find this C. So 2 pi F Xc, 2 times, just put the value. Frequency is 60, Xc is 1000. We get the capacitance. Over here also, C is equals to 1 upon Xc is equals to 1 upon 2 pi Fc. C is equals to 1 upon 2 pi F Xc times 3.14 times frequency is 50 times 1000. And you will get the capacitance. Something like that. Okay. 0.65 microfarad and is 3.18. This is what question is asking. Is there any confusion? I don't think so, yeah. easy, I think. If you know the formula, you will get it. Completed that one, you can go to the question number 11. Look through the question. I'll just write down what question is asking. Then you complete this one. Look over question number 11. In the very beginning, question number 11, it just say that what maximum current. That means you need to find the maximum current I max, and there del V max, it's given that is 48 volt with a frequency of 90 hertz and a capacitance of 3.70 microfarad. Is it capacitance? When connected, goes a 3.70 microfarad capacitor. So yes, it's a capacitance that is 3.70 into 10 to the power minus 6. And question is asking you to find I max. So what will you use to find the I max over here? It's just a simple. I is given, V is given, C is that. In order to find this I max, you use the Ohm's law. Because for the maximum thing, okay, here V max is equals to I max times Z, right? This I max, we need to find this. V max is given. J, it's an impedance. So look at the impedance over there, which is given. Capacitance is given, right? So for a capacitor, you use Xc, isn't it? And the formula of Xc is 1 upon 2 pi Fc. C is given, frequency is given. So we can use Xc, right? So if we can use, we will get it. That is V max, or you can use del V max is equals to I max times Z. So here, instead of Z, I use Xc. So I max is equals to del V max of Xc, which is equals to del V this 48 Xc 1 upon 2 pi Fc goes up, just the mathematical things basic, and I just replace the value. Frequency is 90 hertz, capacitance is 3.70 into 10 to the power minus 6. Here we got the value, which is something like 100 milliampere, or you can just say 100 milliampere. Is there anything? Should I need to explain again? It's just a basic formula, right? This one. And I already told you, if there is just one impedance or just one reactance, then use that. So question number 13, the next one. at the question. What it's saying.
Do you need a new one?
No. I'm just using the one. Another one that's in the back. Yeah, and the question number 13. An inductor has, now look at here. An inductor has, it has 54 ohm reactance. That means what is this? It's XC, right? It's XL, right? That is 50 ohm. So it's the basic things. It's when connected a 60 hertz source, that is frequency, it's equals to 60 hertz. If it's clearly not given about the name frequency, you just look at the SI unit, and if you look at the SI unit, you will know what is given. The inductor is removed, so this is the first case. And second case, here the inductor is removed, that means this reactance is removed. You just don't need to write, because it's already in the question. The inductor is removed, that means this one is removed in the second case, right? Then connected to a frequency is changed from 60 hertz to 50 hertz, and voltage is given. This is our RMS voltage, it's given 100 volt. What is the maximum current? That means you need to find I max volt. So now, remember, very first thing you need to go through the question is what you need to find. And here the question says you need to find I max, right? So in order to find this I max, what are the things given? Inductor reactance is given, frequency is given. It's in the first case. And the second case is also there. For the first case, if frequency is given, XL is given, we can find simply using the formula, that is 2 pi f L. We will get the value of L, that is inductor or inductance. This is 50 upon 2 pi, 2 times 3.14 times, frequency is 60. We'll get the value of inductance, that is no. Yeah. That is something like 0.143 Henry. Okay. We find the inductance over here, that is L, right? Now the next thing is this one is removed, isn't it? So if this one is removed, frequency is changed from 60 to 50. This one is stay as same because it's not changed, right? Question has not says it's changed. So if it's not changed, you just put down this. In the second case, obviously if this is not there, we need to find another XL, another reactance, right? So in order to find that another reactance, let us consider XL dash, the new one. That will be 2 pi, frequency it's new one, F dash. L is same like that. So that will be 2 times 3.14 times 50 times L, that is 0.144. So what will be the value of XL dash? It's something like 44.9 ohm. It's 44.9 ohm. So now you get the resistance, isn't it? This is also resistant. And in order to find I max, another thing is given, that is VRMS. So for VRMS, we can use simple Ohm's law. VRMS is equals to IRMS. You cannot write here RMS and normal I. I also need to be root mean square times the resistance is this one, that is XL dash. So put the value, you will get this one. That means IRMS is equals to VRMS upon XL dash. VRMS is 100 and it's 44.9. You get the current over here. That is something like 2 point something. You just see. It's 2.23. Now the question is I max, right? but we find IRMS. So there is another formula, basic, it's a theorem as well, that is IRMS. IRMS is equals to I max upon root under 2. That means this is given, I max is equals to, this one is 2.23 times root under 2. This will be like 2.15. So we get this value. This is what we need to find. Look at again from first to last and see if there is any confusion. There was two cases. One, there was 50 ohm reactance. Later on, we find the inductor from there, inductance from there. Later, this one is removed. That means if this is removed, we need to find the new one, right? So in order to find that new one, we use the dash one. You can just write XL1 as 2 as well and that 1 as well. But I wrote in this way. There is new frequency F dash. So we use the formula, we get this one. So we get the resistance from here. So we can use the Ohm's law. Vrms equals to V equals to IR. V is RMS, I is RMS. Resistance, instead of this, there is XL dash. So we get the value of RMS and we use the formula this and we get the maximum. Yes?
Could you, instead of doing that, get the Vmax from the VRMS and
Yeah.
just come on?
Yeah. We can do it that way as well. From here, if you find Vmax upon root under 2, you get this, right? And the same thing you use Ohm's law to find. So it's the same thing. Is there any confusion? We can go with the next question. It's question number 14. This is also very simple. Look at the question once. An AC power source has an RMS voltage. It's very simple. RMS voltage is given, that is 120 volt. Frequency is given, that is 60 Hz. If a purely inductive circuit is made from the power source and a 47 Hz inductor, determine the inductive reactance. That means here inductor is given or inductance is given, that is L, which is equal to 47 Hz. The question is asking you to find inductive reactance, that is XL, RMS current, that means I RMS through the inductor. So here, in order to find this one, it's very simple. The formula, that is 2 pi f L. You just put the value there, that is 2 into 3.14 times frequency times L, that is 47. You will get XL. It's something like 17718.6. I don't know if it's correct. You can just use your calculator. It's a basic thing. And we get this one. Now we need to find RMS. VRMS is given, just use the Ohm's law. Same like that one. That is using Ohm's law, which is equals to VRMS is equals to IRMS. And for here resistance, XL is given. Use XL over here. So you need to find IRMS. VRMS is given 120. This is equals to 1771.8.60. And you will get answer something like 6.77 into 10 to the power minus 3 ampere, which is equals to 6.77. It's less than that number, right? We need to find I max. You can go further if the question asks you to find I max. You just use I max. If B max, you can get it. If Z, obviously this is a Z, right? So yeah, this is just a little thing. And there is a last question, and I think that question include all the impedance things. So we will do that. That is question number 71. I think we did a lot of questions today, right? Then sometime we need to at last because this all thing applies in this question. Look at the question once. Question number 71. Understand the question? You can go through that as well. I'll just read out the question. As a way of determining the inductance of a coil used in a research project, a student first connect the coil to a 12-volt battery. Tell me, it is a DC or AC? 12-volt battery. Can you tell me what is that? Because I have already distinguished the DC and the AC. It's a DC. Why? Because it's 12-volt battery. There is no RMS things over here. So there is DC current over here, and it measures a current of 0.630 ampere. The student then connect the coil to a 24 voltage RMS. Now tell me, it's AC or DC? It's AC, yes. So here are two circuits. One is DC circuit and another one is AC circuit. So here is DC and AC. You don't have to distinguish it. You just write down directly and just distinguishing it. So here there is DC and AC circuit. You don't have to do this. I'm just explaining the thing. The student that connect the coil to a 24 volt RMS 60 Hz generator and measure an RMS current of 0.50 ampere. What is the inductance? So here resistance is given and inductance you need to find. So can you tell me which circuit is this? RNI, RNL? It's an RL circuit, right? So you just draw the circuit, so it will be easier for you to know. So in the first case there is 12 volt battery. So this is resistance, this is, right? Is there any confusion after here? No. So here the question is saying, in the first case, voltage is given, it's 12 volt, current is given, it's 0.630 ampere. So it's a DC current, there is no inductance and there is no capacitance, right? It's just a resistant thing, isn't it? So you can simply use, or you can just write here some explanation over here. Here, the opposing, or you can say the current is opposed by resistance only. So, using Ohm's law, V is equals to IR. You can get the value of R. V is 12 divided by 0.630. Get the resistance, which is like something like 19.05. So we get the resistance, right? Now in second case, what is that? The student connect to the coil to a 24 volt RMS 60 Hz frequency is here. In a second case, this one comes, right? And measure an RMS current of 0.50 ampere. What is the inductance? That means in first case there was just resistance, but in second case, this and this both came, right? This one and this one both included in the second case. So in the second case, what will you do? Here, the current is opposed by both resistance and inductive reactance. can use simply using Ohm's law. Now tell me, I wrote here V, it's RMS, IRMS. Now what should I write over here? Instead of resistance, can you tell me what will I write here? Because it's of both resistance and reactance, I cannot just write down R here, right? Or XL here. So which is the one word or which is one symbol that include both resistance and inductive reactance? G, yeah, it's Z or Z, right? It's an impedance or it's a combination of resistance, inductive reactance, or if capacitance is also given there, then that one as well. So we can find the Z or Z, that is V, it's 12, no, RMS, VRMS it's 24, look at the question, and IRMS is also in the question, which is 60 Hertz, I 0.570. So what will you get from here? The value of Z or Z, something like 42.11 ohm. So now here we get the value of G as well. Question asking you to find the inductance, that is L. In order to find this L, we need to find XL, right? So in order to find this XL, Z is given, R is given. Now we get the R, we get J. So now using certain formula, that is Z is equals to, here write down in RL circuit. Don't forget to write the circuit name, okay? In RL circuit, Z is equals to square root of R square plus XL square, right? So you need to find XL square. That means squaring both sides, you will get Z square equals to R square plus XL square, simple mathematic things. So XL is equals to root under Z square minus R square. Replace the value, 42.11. Resistance is 19.05 square, and you will get the value of XL, that is something like 37.6 ohm. So here the student then connect the coil to a 24 volt RMS and 60 Hertz, that means frequency is given 60 Hertz generator, and measure RMS current is 0.570. Now frequency is given, XL is given, so we can use, or we can say, we know XL is equals to 2 pi f L, right? So L is equals to XL upon 2 pi f. Every single value over here is given, you just replace that. XL is 37.6, 2 into 3.14 times. Frequency is given here, 60, so you will get 99 point something. 100. 99.6. Look at this question again. Tell me if there is any confusion. You just go and understand which circuit is given. It's RL circuit, right? In RL circuit also, you also need to know which resistance you should use. So in first case, there was DC. In DC, these things won't come, right? It's only in AC current, AC circuit. So in this DC circuit, it's a simple Ohm's law. You apply it, you will get it. And the next one, there is AC. In AC, both of the resistance comes. So just we are using the Z because Z is a combination of more than one resistance, which is also known as impedance. We just use the value over there, and we can get the value of XL. If we get XL, or that is inductive resistance reactance, then we use that and find out inductance. Is there anything? So we completed 7 questions today. I hope you understand as well. because in the paper it says that complete all the questions because it's useful in your exam. That's why we need.
Will our quiz on Thursday be
I think so.
new stuff, or will it be what we're gonna see on the exam too?
I have no idea because the question is not yet written because it's on Thursday, so it will be uploaded on Wednesday. For me, like I will get the question on Wednesday.
Oh, okay.
Yeah. So
You know, you could ask him to, put the answer key for the quiz on at like noon on Thursday, so that we can see what the answers are before we take our final.
I can try and tell him. Yeah, I will mail him and tell him. Yeah. If you find any confusion, you can just tell me, and you can come in my office hour as well, or you can mail me. Simple thing. If you don't want to come, you can just mail me. I can explain you there. It's easy.